热軋钢卷生产流程重点对照表：原料铁矿废钢，功能说明提供炼钢原料，生产目的生产液态铁水作为后续炼钢原料，管理重点原料纯度、力度、水分含量、储运安全。高炉功能说明熔炼铁矿石产出铁水，生产目的制造高纯度铁水，管理重点炉温控制、焦炭品质、出铁节奏、安全。转炉或电炉功能说明将铁水转化为钢水，生产目的去除碳、磷、硫等杂质，控制成分，管理重点加料顺序、氧气吹炼时间、成分控制精度。扁钢胚连铸功能说明将钢水浇铸成扁平状钢胚 slab， 生产目的形成初步固态原料，利于后续压制，管理重点驻留稳定，钢胚表面品质、中心偏息控制。加热炉功能说明将冷却后的钢胚加热至约1200摄氏度，生产目的提升塑性，利于变形加工，管理重点炉温均匀性、加热时间、氧化皮生成控制。除锈高压水除磷功能说明去除钢胚表面氧化皮，生产目的保护闸滚，提高表面品质，管理重点水压稳定、除磷效率、水质处理。粗压功能说明将钢胚初步压延成较薄钢带，生产目的延长变薄钢胚，便于后续精压，管理重点压下量控制，温度维持，版型稳定。精压功能说明精密压延至所需厚度，生产目的获得最终厚度、宽度与表面平整度，管理重点压制速度控制、板厚精度、闸滚温度与寿命。层流冷却功能说明均匀冷却钢带，生产目的控制钢材微观组织与机械性质、强度、韧性，管理重点喷水压力、温度曲线、冷却均匀性。卷取盘卷机功能说明卷成钢卷便于储存与运输，生产目的形成热軋钢卷 HRC， 管理重点卷区张力控制、钢卷内应力、卷区表面保护。
Hello everyone. Metallic sheets are used in many applications in our daily lives, like car bodies, electrical appliance frames, air-conditioned ducts, and metallic furniture. But how these metallic sheets are produced? This video will give you, as a student, an overview of the hot rolling process that used for metallic sheet production. Hot rolling is a deformation process where the steel material is plastically deformed at very high temperatures. This is done using rotating rolls to reduce the thickness of the material and produce long strips. We will be going through the various stages of the hot rolling process. Each stage requires both knowledge and experience to ensure a high-quality product. In the beginning, the material is heated in the furnace, rolled in the roughing mill, coil boxed, roll in the finishing mill, then finally, cooled and coiled. Before the slab can be processed, it must be heated. The slab is continuously cast and has the dimensions required for the final product of a correct weight, width, and thickness. These furnaces heat the material to about 1200 degrees centigrade. At this temperature, the steel has a sufficient ductility to be easy to deform. The heating is especially important as it affects the properties of the material. If the material is not sufficiently heated, incorrect material properties will arise. This is due to carbides and nitrates failing to dissolve. During the heating process and transport to the roughing mill, the hot material reacts with the oxygen in the air, forming a layer of oxide known as mill scale on its surface. If this oxide layer remains during rolling, it risks being embedded into the steel, negatively impacting the surface quality of the final product. Therefore, the material must undergo mill scale removal before rolling. To cleanse the surface, water is sprayed at a high pressure of 160 bar. After the material has undergone a surface cleansing, it's sent to the roughing mill. Here the material is rolled from its original thickness of 22 centimeters down to about 3 centimeters. This is a very significant reduction. At this roughing mill, a powerful 4-high rolling mill is used. That is, 2 backup rolls and 2 smaller working rolls. The backup rolls are often cast steel rolls. The working rolls must have very smooth surfaces and tolerate high temperatures and wear, as they are in direct contact with the material. This particular material is rolled with 5 passes, where 1 pass means that the material passes through the rolls once. The material is surface cleansed several times during the roughing mill process to remove any new traces of mill scale. In order to control the width of the material, vertical rolls are used. The material is now called transfer bars. After the roughing mill, the transfer bar is rolled up in a coil box. The coil box's primary purpose is to save space, but when inside the coil box, a temperature equalization also occurs. The temperature difference between the ends of the material is minimized as the transfer bar is coiled together. When the transfer bar is removed from the coil box, it has a temperature of about 1050 degrees centigrade. The ends of the transfer bar are cut off and the bar undergoes further mill scale removal. After this, it's time for the next stage, the finishing mill. This mill consists of 6 stands in the shape of 4 high rolling mills. Here the transfer bars, now called strips, are rolled into a thickness of between 16 and 1.8 millimeters. Between the rolls, we see an upper looper, which measures and controls, amongst other things, the line's speed and the strip tension. The swinging motion that can be observed is when the up looper is adjusting itself. In order to control the profile and the flatness of the strips, the working rolls are horizontally adjustable. The first stands control the profile and in the later stands the flatness is controlled. It's very important to have a correct strip profile and flatness before any post-processing starts. The cooling rate is adapted to each strip to produce the appropriate microstructure and material properties of the end product. When the strip is passed through the cooling section, it's coiled in. The temperature during coiling varies between 150 and 750 degrees centigrade. Depending on the properties assigned to the material, after coiling and the subsequent cooling, the strip can be sold directly to the customer or undergo additional processing stages, for instance, cold rolling.
以上影音介绍说明仅代表个人观点，供大家学习交流，不代表公众意见。